Yesterday I recorded, and I forgot to turn my microphone on.
So you didn't record it.
So I've recorded the screen, but all you hear is like static in the background. So when I posted the video for yesterday, I used last year's video. So if you go back in at any point because you want to review stuff on 1.3 before a quiz or a test, just disregard any of the stuff I'm talking about with just classroom activities because it's not this year, it's last year. And I'm recording now for 1.4, so I think everyone is here, though. It's on. I've checked it, yes. We will have a quiz on Tuesday, sections 1.1 through 1.4. Okay. I have left 1.1, 1.2, 1.3, and the web work orientation open until Monday night. This week's, everybody's just kind of getting used to things, so if you haven't finished, I'm not going to count it late. Okay, so go back in the grade book and see what you might still be missing, and make sure you get that done over the weekend. 1.4 will be open until Tuesday night. And then starting next week, I will start being more, I will expect that you get the homework done on time if you want credit. Okay, but if you are stuck on a problem and it's due that night, and you send me an email or something and just say, I really need help, can I come in the morning, will you open it back up for me? If you are going to go to that effort, it's more important to me that you understand it than I've got to follow my strict guidelines of I'm going to drop 10% because it's late. So if it's just you didn't do it and then a week later you're like, oh, I wanted to finish that, then you'll have the late grade. But if it's real time and you need some help, I'll work with you. Okay, and not give you problems. Yeah.
I won't be here on Tuesday, so do you just want me to take the quiz on Wednesday?
Yeah, that's fine. Yep. Okay, so 1.4, again, this should be review of Algebra 1, solving equations with 1 or 2 steps. Okay, just pretty straightforward. I mean, if I have something like that to solve, I'm just going to undo by dividing by 2, and I get x equals 7/2. Or if I have something a little more complicated, then I've got 2 steps here. The first step is I undo the addition with subtraction. Sorry. Divide by 3, and x equals 6. Right? So this shouldn't be anything new, hopefully. Pretty straightforward. Okay, so what I want to show you, though, is that least common denominator method that was talked about in the textbook. Because I'm going to do a problem, and I'm going to do it without using the method, and then I'm going to do it with using the method just to show you the difference and show you why you might want to learn the method, because it's a lot easier to deal with. Okay, so let's do this problem. 3/4 x minus 2/3 equals 7/3. So how many of you out there, and actually I want to make this something even more difficult, 7/5. How many of you out there love working with fractions? It's like if you could do math all day long with fractions, it would be like great life. Anyone love fractions like that?
I just don't want to do that.
Okay, so to do this problem, the first thing I'm going to do is add 2/3. Right? So I get, and I've got to add 2/3 to this side, 3/4 x equals 7/5 plus 2/3. Now over here I've got to get a common denominator of 15. So 3/4 x equals, you guys, I'll show you a trick on how to do fractions, adding and subtracting. And you'll learn this too when you do John Baylor. But if you multiply the 3 times the 7, the 5 times the 2, and the 5 times the 3, you get your fraction. Crisscross method is what John Baylor calls that. So this becomes 3/4 x equals 31/15. Now what do I do? Or multiply by the reciprocal. Okay? Yeah, so then I get what? 124 over 45. And there's my answer. Right? Kind of painful. So let's start with the same problem and use the least common denominator method. What is the least common denominator of these three? Does 4 go into 30?
60.
Yeah, I'm thinking 60 is the smallest one. So, the least common denominator is 60. I'm going to multiply everything here by 60. If I multiply it on the left and I multiply it on the right, it doesn't change the equation as long as I do to the left what I do to the right. So I'm going to multiply everything on the left by 60 and everything on the right by 60. Okay, so what is 60 divided by 4? 60 divided by 4.
Oh, wait.
15.
15. And what's 15 times 3?
45.
What's 60 divided by 3? Times 2. What's 60 divided by 5?
12.
Times 7? 84. Right?
Oh.
Now I don't have to deal with fractions anymore.
Yeah, because now you can. It's so much better.
Could you go over the steps again?
Yep. I'm just going to show you here.
Now you still have a fraction.
Answer's the same.
Wait, so where did you get the 60 again?
I found the common, I pretended that I'm adding 3/4 and 2/3 and 7/5. I've got to get a common denominator. So I'm going to get the lowest common denominator.
What's the lowest number that you can multiply something by those numbers to get?
Right.
Does it matter if it's like if it isn't the lowest?
It doesn't matter if it's not the lowest, but then you're going to end up having to simplify at the end. Okay, so what we did, I'll go over these steps again. I found the lowest common denominator of these three numbers. Okay, so what I did, I mean, you could just, to find the denominator you want to use, you could just take 4 times 3 times 5. This time it worked. We got 60. Sometimes if you multiply those three, it's not the lowest.
But
Let
it
me-
still works?
And like this one, my least common denominator is 12, right? But if I multiply 4 times 3, which is 12, times 6, I can still, which is 72, I could use 72, but then eventually at the end, I'm definitely going to have to simplify my fraction. Okay, so if you find the lowest common denominator, it makes your life a lot easier. So don't just think you can just multiply across and that's the lowest. It is a denominator you could use, but it's not the lowest. In our case, there was no other denominator. 30 was the closest, which you guessed, but 4 doesn't go into 30 evenly, so it didn't work. Okay, so I found the least common, or the lowest common denominator. You said,
I said 3.
well, that's even worse.
I thought I wasn't thinking lowest common denominator. I was just thinking the least,
The lowest number?
Yeah, the lowest number that's in the denominator.
Okay, yep, so we're thinking of the smallest number, all three of these go into evenly. Okay, all right, so then what I did is once I got that number, think of it like this, 60 over 1, right? So if I'm just going to talk about this fraction here, 3/4 times 60 over 1, remember how I told you last week you can switch that denominator and simplify rather than multiply across? So in my head, this is what I do. It's 3 over 4 times 60 over 1 is the same as 3 over 1 times 60 over 4, right?
Yes.
So 60 over 4, we said was 15, and then we multiplied it by 3 over 1, which is 45. So I'm taking 60, dividing it by the denominator, multiplying it by the numerator.
Oh.
Then I'm taking 60, I'm dividing it by 3, which is 20, multiplying it by the numerator, which is 40. Then I'm taking 60 and dividing it by 5, which is 12, multiplying it by 7, which is 84. And by doing that, I just I get rid of all my fractions in one fell swoop. That makes sense? Okay. So I preferred this method. You can still do it this way and do all of your fraction work all the way through the problem. But to me, using the least common denominator method is a lot cleaner and a lot faster, and I don't have to deal with fractions when I do it. I get rid of the denominators, basically. Want to try another one?
Yeah.
I don't know what I want to use here. I don't want to use 7. Let's do 3/4 fourths equals 1/6. So what is our lowest common denominator?
20.
We could use 24, but it's not the lowest. Okay, so we could take 3 times 4 times 6, but there is definitely one lower, and it's 12. Okay, so I'm going to take all of this, I'm going to multiply it by 12 over 1. So now I'm just going to start with this. I'm going to distribute this 12 to each term in the equation. 12 divided by 3 times 2. 12 divided by 4 times 3. 12 divided by 6. That's a lot easier than trying to solve it this way. Okay, just a trick. You don't have to use it, but it's definitely something that could speed up your time on the ACT if you get a fraction question. Okay, let's look at the textbook check. And this is 1/4. Okay, I added a comment to the first video on solving two-step equations. What was the comment?
Oh, it was at 5x.
I like to add 5x to both sides so that x ends up on the left side. Yeah, so you don't have to do it that way. For me, I just like the equation when I'm solving it to have my variables on the left and my constants on the right. Don't have to do that. But I normally will do that if I end up with a problem like this. I don't want to do that. Something like that, where I've got a negative x. Well, if I were just to switch those, in my mind, it just cleans it up. If I add the 2x over and subtract the 5, I end up with 2x equals negative 5 minus 7. And now I've got a positive x value, and it's on the left, and it just keeps it straight in my mind. I'm a little OCD. You don't have to do that, but that's something I like to do.
Divide by 2 and solve for x.
Yep, negative 6, and there you go. Okay. Next one. In the section on solving two-step equations, both the video and the textbook refer to the least common denominator method. In the problem below, what would you multiply each term by using this method? Well, it'll be 12. That's the least common. 24 works, but it's not the least. And 6 and 4 definitely don't work. All right. In the first page of the textbook, there was a real-life problem discussing two friends. According to the textbook, what state did they live in? California. When solving for x in the following equation, what number would you multiply both sides by? 4/5, the reciprocal. So just do it at the same time. Save yourself a step. In solving two-step equations that involve addition, subtraction, and multiplication division, the first step is to undo an operation using multiplication division. That's false. Because we always undo addition, subtraction first, and then multiplication division. It's the reverse order of PEMDAS. PEMDAS says multiplication division. SADM. Something like that. SADM. Yep. Okay. Everybody good? So, yes.
I have a question on the web work.
Okay.
So my problem is 4p divided by 11.
plus 12 equals 28?
Yeah.
Okay, so your first
I'm at
step,
the point where I've got to 16 by minusing 23 12. I'm just wondering, what do I do first? Do I times it by 11 or do I divide it by 4?
okay, this is 16. So we could just multiply it by 11 fourths,
Oh,
the reciprocal.
And then you can just
Yeah,
cancel them out, and
that's
then you just
simple.
have P left, right?
And 16 over 4 is 4, and 4 times 11 is 44.
yeah. Thank you.
Any other questions? Problems you want me to do for the group?
Yeah, I have some on that point.
Okay.
So it says solve for the equation P equals 1 plus 2W 4W.
Oh, that's an L.
That's an L.
It's an L.
2L plus 2W what? Oh, 4W. So we want to solve for W. So we want to get W all by itself.
Okay.
Okay?
But where do we put it with the P though? If the P's are divided.
Well, we're going to manipulate algebraically this equation so that W is by itself.
Okay.
Okay? So we want to get this term by itself first. So I'm going to subtract 2L. So this is P minus 2L equals 2W.
Let me divide by 2 L.
Did you see that? This is just a number. If it was P equals 2 plus X, and I wanted to solve for X, I'm just going to subtract 2 from both sides, right? So this is just a number. It's just 2L, where L could be any number.
But it doesn't have to be like W equals, it can be 2W.
Well, I'm not done yet. I'm just showing you this step. Okay, and now I need to get W by itself, so I divide by 2. And now I'm done. So this is what you type in. And make sure that you're putting parentheses around the numerator. Otherwise, it's going to follow PEMDAS. If you just type in P minus 2L, and then you do divided by 2, it's just going to take the 2L divided by 2. It's not going to take the P. So you've got to always do P minus 2L, if that's the numerator, in parentheses, divided by 2. Okay?
Why don't we put W equals? This is yeah.
Because it says they want you to solve it for W, so you know that what you put in there is what W is.
It tells us like P is not a defined.
Did you use capital P?